This is lesson 10.2, division with exponents in pre-algebra. We're going to call it 10.2a because I'm assuming we're going to have a couple videos. First of all, we did our multiplication of exponents, and you found that when they were close together, or when they were multiplied like that, bases were the same, that equaled 3 to the 2 plus 3. When we had them written like this, close together, it was 3 to the 2 times 3, which gave us 3 to the 6th, and this gave us 3 to the 5th. So a big difference in our answers. Alright, so in this lesson we're going to look at the division of numbers with exponents, and what we're going to do here is, if you have a number such as, and I think I'm getting ahead of myself a little bit, but if we have a number like 3 to the 5th, and we have that over 3 squared, as long as the bases are the same, we just write the base. We write the top number minus the bottom number. So that would equal 3 cubed. Okay, so it's real easy to do that. You know what the top number is, you subtract the bottom number, and you know you've got your answer. So you can pretty much do this in your head. Be able to just look at the 3 to the 5th over 3 squared and go, oh, 5 minus 2 is 3, so it's going to be 3 cubed. So if this is x to the 5th over x to the 1st, you're going to get x to the 5 minus 1, which is 4. They have some negative symbols on their exponents in this first example here, and this is where I think they got ahead of themselves a little bit. But whenever you have a number with an exponent that's negative, it obviously does not mean 2 times 2 times 2, because that is 2 being taken times itself 3 times. How do you take something times itself a negative number of times? Well, that negative sign does not mean a negative 3 on here. It has a different definition. When there's a negative sign here, it means that the base number and the exponent are in the wrong places. Alright, what I mean by that is when we have a fraction, we have the numerator and we have the denominator. Now when we make this into a fraction, what we're saying is that with this negative here, this 2 and this 3 are in the wrong position. They're in the numerator position, and they actually should be in the denominator position. So if we want to get rid of that negative sign, we take the base and its exponent and move it to the other position. And when there's nothing left on top, you always put a 1 there. So now my exponent is positive, and now I can actually do the work. 2 times 2 times 2, so 1 over 8. So that ends up being the answer to 2 to the negative 3rd power. So if I have something like 3x to the negative 6, what does that mean? That means that the base number and the exponent are in the wrong places. The 3 doesn't have a negative 6 on it, it's just the x. So the x and the 6 have to move positions. So the 3 is going to stay where it's at, but the x and the 6 are going to move down below. Now it's in the correct place, we don't have a negative on there, and now we can proceed. So that makes our life easier when we get rid of those negative signs. Alright, so let's look at example 2. Example 2 is just doing some of those basic division that we had shown earlier. When we have something like x to the 9th over x to the 6th, that equals x to the 9 minus 6, which equals x cubed. When I have something like x to the 4th over x to the 10th, that equals x to the 4 minus 10, which equals x to the negative 6th. And again, what that negative sign means right here is that the x and the 6 are in the wrong place, because that can be written like that. It means that it shouldn't be on top, it means that it should be on the bottom, and then we can take the negative sign off. So our answer then is that right there. Alright, so when we have 2 to the 15th over 2 to the 20th, we get 2 to the 15 minus 20, which equals, minus there, 2 to the minus 5, and again, it's in the wrong place, so 1 over 2 to the 5th, and 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th is 32, and that's what we get for our answer. Now we've already done some problems very similar to this. When we have something like 2/3 and we square it, that means the top number is squared and the bottom number is squared. So we get that for an answer. If we have a variable on there, we cube the top number and we cube the bottom number, and we're done. If we've got a variable on the bottom, that equals 5 squared over x squared. 5 squared is 25, and we cannot square x because we don't know what number it is, so it stays x squared. If we were to do something like 2/3 to the 4th power, that's going to be 2 times 2 times 2 times 2 over 3 times 3 times 3 times 3, 4 times. So this next part of 10.2 is 0 and 1 as exponents. And for the most part, it's pretty simple. Any number with an exponent of 1 is that number, because there's nothing that we're multiplying it by. Any letter with an exponent of 1 is that letter. So that's not too bad. One of the things that we run into, remember when we were showing like x cubed over x squared, and that equals x to the 3 minus 2, which equals x to the first, which equals x. What happens if I have x cubed over x cubed? Well, any number over itself is 1, right? But let's go this way. That also would be x cubed minus, so it would be 3 minus 3, because we're going to subtract those, which gives us x to the 3 minus 3 is 0. So this equals 1, but it also equals x to the 0. Therefore, any number to the 0 power equals 1. So if it's 3 to the 0, it equals 1. If it's 119 to the 0, if it equals 1. If it's y to the 0, it equals 1. So just something to help you there, and it will make your life easier, especially when you run into something like example 4D. It gives you 2x squared y, and then it has it to the 0 power. Because that 0 is in the outermost place, the answer is 1. You don't even have to do any work. If we had a problem like C, 4 to the 0 plus 4 to the first, that number right there is 1. This number right here, 4 to the first power, is 4. Add the two together and you get 5. So let's look at example, I guess it's example 6. They give us x to the negative 8, and they put that over x squared, and then they cube it. So we're going to leave our x to the minus 8 alone right here, and we're going to do what they have down here, and we're going to make that x to the 6th. Alright, so what it's telling me at this point is two things. It's telling me that my x to the 6th is in the correct place, but it's telling me this is in the incorrect place. So I can make this negative a positive by moving that x to the 8th down, getting rid of it up there and putting a 1 there, and then I add those two together, and I get 1 over x to the 14th. Alright, let's look at another way of doing this. So I'm going to write the same problem down. And again, I'm going to leave my x to the -8th alone up there, and this will be x to the 6th. Now, what I can do here is I can write this as x to the -8 minus 6, which is x to the -14. So now that's telling me that's in the wrong place, so I'm going to put the x in the bottom, and there's a 1 on top. So either way will give you the right answer. As long as you're following mathematical procedures, you're going to get the right answer, and it won't be a problem, even though it may be different than what the book says as far as a way to do that, or a particular way that it's being taught. Now let's look at example 8. They give us 3x to the 5th, and they're taking it to the -2 power. So first thing we're going to do is get rid of that doggone negative there. So that is written like that. So let's move the 3x to the 5th down, and we'll put a 1 above. We did not take this 1 and move it over. Don't get the idea that we're just inverting it or we're flipping it over, because that's not what's happening. You can get into a lot of mistakes if you start doing that. I had a math teacher friend of mine that taught their students to do that, and it made some real problems there. Okay, so 3 squared is 9. X to the 5th squared is x to the 10th, and we're good to go. Okay, so this is example 10. So this one looks a little tricky, but let's just take one bit at a time. So we're going to do this part right here, a to the 6th, a to the -4th. We'll just leave that alone. Down here, we're going to write this as a to the -12. Now, in our numerators, our bases are the same, so we're going to add our exponents, a to the 6th plus a -4. So we're just adding these two over a to the -12. That gives me a, add those together, squared over a to the -12. Okay, I know that my -12 is in the wrong, or my a to the 12th is in the wrong place because of that negative. So let's move it up to the right place. So a squared, and then we'll put a to the 12th. Now when you move these up with something else, it's multiplying. You're going to be multiplying it by the a squared. And now we have as our answer a to the +14. So see, by moving this up, it allowed us to have an answer with an exponent of +14. Alright, so that's all for 10.2a. Now we'll start on 10.2b.